Alright, Calc 3, good morning. Little do you know, this is actually my second attempt at this video. I started the video, I hit the power button, I came back and it said I could start up again, so I started up again, and then I watched the video and the audio didn't sync up with the video, so now here we are. Luckily you did not see that. Basically it was like the worst video I ever made, so you guys are getting a better one. Anyway, today we're going to talk about surface area. The whole reason we did parametrized surfaces last video was so that we can easily find the surface area. To do that, you just need to do a double integral with the parametrized surface equation. You need the partials of the surface. So whatever variables you have the parameterization in, you need to do the partials with respect to those variables. It is considered smooth if the partials are continuous and the cross product is never zero. Okay, again, pause your screen if you need to keep writing. I go fast on the videos because you guys have the ability to stop me and watch the screen and then pick up. So, alright, so therefore we get now to the equation for the area of a smooth surface. Notice how it is just the magnitude of the cross product of the two partials integrated over the bounds of those two variables, which the surface is in terms of. So, forms of surface area. You're going to see d sigma. D sigma basically means the surface area differential, and in this case, it's this whole part of the surface area equation. So therefore, we can just sub that in and say, hey, the area of a surface is the double integral of just the surface area differential. Okay, and that's all you need to really know about that. Again, pause the screen if you want to write any of that down, but we're going to go on to the next problem where we are going to practice doing a surface area problem from the same example from the beginning of the notes from yesterday. So, yesterday you guys found that r, in terms of r and theta for this cone, was r cosine theta, r sine theta, and then it was just r. We found that z was equal to r. We also found that r was between 0 and 1, and theta was between 0 and 2 pi. So to do a surface area, once you have your parametrized surface, to do the surface area of this is first you need to find the partial derivatives with respect to the two variables. So we're taking r with respect to the radius, and when we do these three things with respect to r, you get cosine theta, sine theta, and 1. When we do the same thing with respect to theta, we get negative r sine theta, r cosine theta, and 0. So there we go, those are our partials. So the next step in finding our surface area is we need to find the magnitude of the cross product. So first we need to do is find the cross product of these two vectors. Remember how to do that, guys. It's a skill that never goes away. Alright, so I'm setting up my cross product. I'm going to put cosine theta here, sine theta here, and a 1 there, and then I repeat. And negative r sine theta here, r cosine theta here, and 0. And then I just, rewrite the first two again. Okay. So, it's the downs minus the ups, so there's 1 down, 2 down, 3 down. And then the ups are here, here, and this one's going to be 0, which is great. Okay, so we get, that's a 0, we get a negative r sine theta in the j direction, we get an r cosine squared theta in the k direction, and then it's minus the ups, so minus a negative, so that's going to become a plus, r sine squared theta in the k direction, and then minus, and it'll stay minus because there's no negative there, in the I direction. So therefore, the cross product, I'm opening things left and right. This is what happens when you're not on a table and you're just like doing this in your lap here. So we get I is negative r cosine theta. J is negative r sine theta. And then notice that k is this plus this. Well, you can factor an r out, and then you guys should know that sine squared plus cosine squared is 1. So therefore, this is just r. So now we need to find the magnitude of this. So basically, I'm finding now the magnitude of r cross r theta. Okay, so remember, to find a magnitude, you just take each component of the vector that you're finding the magnitude of, and you square them, and then take the square root of the sum of those. So we get r squared cosine squared theta plus r squared sine squared theta and plus r squared. Hopefully you guys noticed that the first two pieces, r squared cosine squared theta and r squared sine squared theta, just become r squared. So what you have under your square root is an r squared plus an r squared, which is the square root of 2r squared. And you can pull that r out, so we get that the magnitude of the cross product is r square root of 2. So now that I have the magnitude of the cross product, I can set up my surface area equation. The area of this cone is equal to my bounds. I'm going to do r first, and then theta, just because, why not? Doesn't really matter in this case. And then we put our surface area differential, which is basically just this cross product here, r root 2, and then it's the dr, the change in r and the change in theta. So there is my setup. So because I had the parametric equations, I was able to find the partial derivatives, take the cross product and the magnitude, and now set up my surface area equation. Let's just solve this now. We integrate. We get r squared over 2. I'm going to pull the constants, the constants out. That's the 1/2 is the 2 on the bottom. And I get that this became r squared from 0 to 1. You plug a 1 in, you plug a 0 in, you just get a 1 d theta. So this just turns into this integral here. And that'll just become theta, which turns into 2 pi. So you get 2 pi times that, which is just pi root 2 square units. And that is the surface. Oh, I left a lot of room on this time. That is the surface area of that cone. Okay? Hopefully that video went way better. It was even like 2 minutes shorter. I don't know what I was doing last time. You guys are very fortunate. I just decided to redo it. It was bad. Anyway, tomorrow we're going to show how to do surface area when you do not parameterize the surface and you just use what's given, and that's called the implicit form. Okay? Tonight for homework, I'm just going to have you guys do, again, this is for e-learning. If it's another year, then don't worry about this. You have your own homework. But you guys will do 3 of the ones you did yesterday, but now you're going to find the surface area of the ones that you parameterized yesterday. So make sure that you listen to my comments about yesterday's answers so you know that you have the right answer before you begin. Okay? Alright, I will see you guys later.